Welcome to SCARLETT. SCARLETT, which stands for Scalable and Reconfigurable Electronics Platforms and Tools, is an EC-funded FP7 First Call project coordinated by Thales Avionics. This presentation will provide you with a general overview of processes and tools for Next Generation IMA. IMA second generation will provide the system designers with more options in terms of computing power and communication means. The number as well as the criticality of integrated systems in the aircraft will increase. From technology and process point of view, it follows that IMA integration becomes more complex. One SCARLETT objective is to provide optimized processes and tools for the use of next generation IMA technology in future aircraft programs. Why are new processes required? Two main reasons have been identified. Firstly, technical innovations in the IMA technology impact processes and tool chain. These are new equipment types, PF functionality, additional tools, and methodology. Secondly, airframers in Europe have demonstrated successfully the feasibility of the development of the new architecture and integration process. However, IMA introduces considerable additional effort for system designers as well as for IMA designers. Additionally, the current process does not result in an optimized aircraft architecture. The existing process shall be optimized so that the required resources and development time is minimized and the design maturity is maximized. In previous aircraft programs, the design maturity level required by the customers at TIS was not fully achieved. The full maturity of the aircraft platform was completed after the original due date. Consequently, airframers have had to spend additional time and budget to achieve the required maturity level. In future programs, the goals will be to reach a respective EIS maturity earlier in the program and improve the overall design maturity level of the system architecture. This is achieved by optimized validation, evaluation and verification activities on platform level. Thereby, the basic integration philosophy does not change. Airframers will still follow the tried and tested methodology of incremental certification. Each system hosted on the IMA platform can be qualified individually. Three main tasks have been identified that will help to achieve the objectives. Firstly, introduction of new tools. With the introduction of IMA, the system designers have been faced with more complex technology and processes. System design cannot be seen as standalone anymore, but requires harmonization with the new platform architecture approach. The governance and control of the design steps are supported by introduction of new tools. Secondly, development of a seamless tool chain. The airframers follow the waterfall process defined in the V model. This process shall be supported by a seamless tool chain where the output of one tool can be used directly as an input of the following tool without manual interaction. The design process will move towards a paperless workflow where design data remains in electronic format. Paperwork shall be generated only for validation and qualification activities. Thirdly, standardization. A standardized configuration format is a means to harmonize and ease the platform configuration. For example, if each equipment type used in the platform requires its own configuration format, then there will be multiple configuration processes and therefore the complexity of the complete platform configuration will become unmanageable. Introduce new platform design tools. This slide lists a subset of tools developed in the SCARLETT R&T program. The Early Validation Tool, EVT, helps the platform designer to allocate platform resources for system functions. Architecture evaluation is supported by automatic application of respective criteria and constraints. The output of EVT is an optimized architecture. The multi-equipment simulation tool provides a simulation environment that allows several respective applications to run in parallel. The validation of system functions that are distributed on several equipments is therefore eased. The Smart Configuration Databases eases time-consuming system and equipment configuration work. Checks during the configuration definition reduce development and test efforts. Clearly defined responsibilities for the configuration work share between partners will enable lean design processes. The platform framework provides the backbone for the development of seamless toolchain. SCARLETT applies the SOA technology and uses the Eclipse framework as a basis to provide a common HMI. Introduce a toolchain that supports seamless integration between design steps. The IMA platform development and system integration is performed in 6 main steps. Each step requires one or more specific tools. The top-level requirements at aircraft level are still defined in a text document. The function modeling step, textual requirements are interpreted into system functions. Several modeling languages are available for function modeling. For example, SysML and MATLAB are widely used. Additionally, SCADE is used for critical functions. In the PF evaluation step, the modeled functions are mapped on hardware. Architectures are identified and their compliance to predefined criteria is evaluated. There are different compliance criteria that may be evaluated by different tools. In SCARLETT, a network and architecture evaluation tool has been developed. In the PF configuration step, the selected architecture of the previous step is completed by equipment-specific configuration data. A standardized configuration format simplifies the configuration of equipment from different module suppliers. In the frame of SCARLETT, a standard configuration format and the supporting CFE tool have been developed. The output of the PF configuration is used as an input for the platform simulation tools. Based on a given configuration, the application coding can be finalized. In SCARLETT, the platform simulation tool, PFS, has been developed. With the PFS, applications can be validated without the availability of real equipment hardware. Applications with the respective configurations are verified in the PF verification step. An extra verification step is required when respective simulations are not fully representative for certification issues. Different tools for automated configuration tests and functional verification have been developed in the frame of SCARLETT. The results of the PF verification step are verified loads that are ready to be loaded on the aircraft equipment. A seamless toolchain helps to accelerate the design process and increase the maturity of the applications and configuration tables. Standardized data exchange formats and tool interfaces. There are several areas of standardization. Amongst others, SCARLETT investigates the use of standardized configuration table format. The IMA platform can rely on equipment from various suppliers. Today, each equipment type has its own configuration format. Each configuration format requires different processes to fill the configuration files. Additionally, each configuration format requires new or adapted tools on airframer side. After completion of the configuration, the module load is produced by module-specific supplier toolchains. Each equipment type will use its own tools to produce a load. In future, both the module types and the module-specific supplier tool chains remain module suppliers' responsibility. Standardized configurations allow the reuse of processes and tool chains for different equipment types and aircraft programs. Conclusion: a standard configuration format allows the reuse of processes and tools. It saves time and money for both airframers and module suppliers. The introduction of new tools, as well as the optimization of processes, will help to improve the design maturity and finalize the design in time. A quantification of the process improvement is possible but difficult. Project as well as product-specific parameters must be evaluated. Project-specific criteria are time, budget and resources savings, and product maturity-specific criteria has parameters like reliability, availability, weight, etc. In previous aircraft programs, the process has been mainly linked to system development. Future processes must consider much more the aspect of platform design processes and their dedicated tools. Thank you for listening. Please visit our website, and should you have any further questions regarding this presentation, please do not hesitate to contact any of the persons mentioned. Thank you for your attention.